Hello, my name is Engineer Holiday and welcome to my YouTube channel. I want to talk about what trigonometrical function of compound angle. And if we want to do that, let's say we draw a rough sketch. And this rough sketch, let's take here as a middle. Let's divide it. Draw a perpendicular bisector. And let's call this one 90. This one 90. Now, what we want to do, let's call this one angle A and let's call this one angle B. Let's call here 0. Let's call here let's say Z. Let's call here M and let's call here N. Let's draw a straight line to bisect this one equally. And let's call this one what? Let's bisect this let's say Q, ZQ. Now this one, let's call it R. So now we have our complete diagram. Now what we want to do now, don't forget that your Q is equal to what? QN. Also, don't forget that your RM is equal to what? QN. Now, since we know that, now let us find sine A plus B. We know that sine A plus B is equal to opposite over hypotenuse, which is a combined angle. That is this angle like this. Now, and that will give us what? Z what? Q all over what? OZ. Now, don't forget that this ZQ bisect this line, bisect OM at an angle of what? 90 degrees. Then don't forget that this particular line bisect what? ON at 90 degrees. Then this particular one that come down, this one is what? Bisect the ON also 90 degrees. So we want to have what? ZQ equal to OZ sine what? A plus B. If you make ZQ the solid formula. Now your ZQ is equal to ZQ is equal to what? ZQ equal to what? QR plus ZR. So once we get that, what we are going to do now is to what? Look for ZR, look for QR. First of all, for us to look for QR, let's use, don't forget QR equal to what? Or RQ equal to QN. So RQ equal to what? NM. Sorry. NM. So that is just that. Now let's look for RQ by way of looking for MN. And MN is opposite to what? A. So we can say sine A is equal to opposite, which is M what? N over hypotenuse is what? OM. So if you make it cross multiply, what we are going to have OM is equals to what? Or OM MN equal to what? ON sine A. Let's take note of that. Now, having gotten that, recall that what? MN equal to what? RQ or QR. So therefore we can say RQ equal to what? OM sine what? A. So this one is equal to this one. So we put it there. So we have gotten this one first. But remember, OM can be replaced also. Recall that OM is an adjacent to what? B. So well, let's say cos B, because adjacent has to do with cos B, for us to involve OM. Cos B equal to OM over what? Adjacent over hypotenuse OZ. So therefore OM becomes what? OZ cos B. Now let us put this one here. In place of OM, let's substitute OZ. So RQ becomes what? Let's put all this one to replace this one. So I would have OZ cos B sine what? A. Let's keep that one first. Now let us do that of what? QZR. Now to get ZR is from here to here. Now to get ZR, don't forget that we would need to what? Use another identity to get ZR. And for us to get ZR, let us use here is equals to also A. This angle is equals to A. So if you draw that ZRM will give us what? A triangle like this. Look at the board. Which is what? Here is now A. This is place. This RM. And here is ZR. So now, if you get that one, we are going to have it as what? ZR. We are going to have ZR. This is adjacent. Now, will be what? Cos A equal to what? ZR. That means we want to use this triangle. ZR over what? Over MZ. Adjacent over hypotenuse. So MZ now ZR will now be equal to what? MZ cos A. Now remember that what? MZ can be solved for. MZ is what? Opposite to B. MZ is opposite to B. So let's say sine B, since it's opposite to B, let's use sine MZ all over what? Hypotenuse, which is what? Opposite. B is opposite over hypotenuse. That means OZ. Therefore, MZ equal to what? OZ sine B. So let us put it there inside the what? The formula for this. Let us replace this one with what? Yeah. So ZR will now be what? OZ in place of MZ now. Sine B cos A. Now let's put all of them there. We have gotten what? ZR. We have also gotten what? R what? Q. So put it in the formula. We would have what? ZQ equal to RQ or QR, which is OZ cos B sine A plus then ZR. ZR is already gotten as what? OZ sine B cos A. So and ZQ is already what? Equal to what? OZ. Now let us put this one to replace ZQ. So if you do that, I would have OZ sine what? A plus B is equal to OZ cos B sine A plus what? OZ sine B cos A. So final answer, if you cancel OZ all through, divide all through by OZ, I would have sine A plus B equal to what? Cos B sine A plus sine B cos A. So this is the first what? Answer there. Now, I haven't done that. Now, let us now look for, let us find cos A plus B using similar case. Now, for us to look for cos A plus B, I have to what? Add these two together, and here is adjacent. Sorry, adjacent over what? Hypotenuse. So it now be OQ over OZ. That is what? Adjacent over what? Hypotenuse. That will give us OQ equals to what? OZ cos what? A plus B. Now, don't forget that OQ can be gotten by what? OQ is what? ON minus ZQ minus Z what? I mean NQ rather. ON minus NQ. So we give us what? OQ. Please take note of that. Very important. Now ON is what? Is adjacent to A. So let's look for it. That will now give us what? Cos A is equal to what? ON adjacent to what? To A over hypotenuse OM. Therefore, ON equal to OM cos A. Let's leave that one first. Then let's go with let's solve for NQ, or let's say OM is adjacent to something. Check, ON is what? OM is adjacent to B. So we can say cos B also is equal to what? OM, since is adjacent to B, angle B over what? OZ. So therefore OZ equal to what? OM equal to what? OZ cos B. Now let us substitute it here in this equation. So therefore ON becomes what? If you put it here for OM, just substitute everything here. We're going to have OZ cos B cos A. Now we are done with that one. Now what do? We now what? Let's take note of this first. Now let us now solve for NQ. Where is our NQ there? NQ is here, or QN. Let's use this, the help of this triangle. ROM equal to what? NQ or QN. So let's use what? Cos A is equals to what? N what? RM, which is this place, over let's use sine, because it's opposite to what? So we use sine. Since it's opposite, it is sine we want to use. RM is opposite to A. So sine A equal to what? RM over what? Hypotenuse what? ZM. So we are going to have what? Therefore RM equal to ZM sine what? A. ZM sine A. Now but recall, there's something I want you to know there. RM equal to what? Or that means opposite over what? Hypotenuse ZM. But recall, ZM is opposite to B, to the angle B. Look at it. This ZM is opposite to what? Angle B. So this one now, since it's opposite to angle B, then that means that we can say sine B equal to ZM over, that means opposite over what? Hypotenuse OZ. Therefore OZ is equal to what? Cross multiply. Then ZM equals to what? OZ sine B. Now let us place this one in place for what? ZM. Therefore our RM becomes what? Place of this one in place of ZM. OZ sine B. Put it in place of ZM. And we have what? OZ sine B sine what? A. So what do we have now? We're going to have as what? The RM is already gotten. So RM is gotten. So RM is also the same thing as QN or NQ. So NQ is equals to what? RM, which is equal to OZ sine B sine what? A. So finally, let us put it in our formula. So I want to have it what? As what? ON minus NQ will now give us what? Will give us what? OZ cos A cos B minus OZ sine A sine B sine A sine B. So that's what I want to have here. Now that is minus. The ball record, this one is equal to something here. What is it equal to? OQ is equal to what? OQ. So OQ now is equal to all this one. So and OQ is now what? OZ cos what? A cos B minus OZ equal to sine A sine B. So what is our OQ? OQ is equal to, from the beginning, where is OQ? OQ is equal to OZ cos A cos B. So we know that, but replace this with what? OZ cos what? A plus B into bracket what? You now replace all this one. There were OZ cos A cos B minus what? OZ sine A sine B. So if you remove or divide all through by what? OZ. What we are going to have as our answer will now be what? Divide all through by cos OZ. I would have A cos B. Cos A plus B become what? Cos A cos B minus sine A sine B. So this one is the final answer. So we are done with that now. So if you want to now get other identity, maybe you want to get sine A minus B. So if you want to get sine A minus B now, in the formula I gave you now for what? Sine A plus B, which is now what? That one is gotten already. Cos B sine A plus sine B cos A. Replace it with what? Replace B with what? Minus B. So what we do that? What do we have? If you replace B with minus what? B, what do we have? So I want to have it as what? Look at the board. That means sine A minus B will now be equals to what? Now be cos minus B sine A plus sine minus B cos A. Now, since it's what? Negative angle, and let's assume that this B is not greater than 90. Therefore, this one now will not be equals to what? Cos B. Cos minus B is cos B sine A. Sine minus B is what? Minus sine B cos A. So that is what this one will give us. Then the last one is what? Cos A minus B. So do the same thing for that one. Do the same thing. In place of B, replace it with what? With minus B. So I would have cos A cos minus B, then minus sine A sine minus B. So what do we have now? Minus, we have fed minus sine A minus sine auto bracket minus B will give us minus sine B. Minus minus will give us plus. So I would have cos A cos B. So I'll give us cos B back plus sine A sine B. So that is cos A minus B. Now what we want to do next now is to look for what? For tan A plus B. Tan A plus B is seen as what? Sine A plus B over cos A plus B. So which can be written as what, class? It can be written as what? Sine A cos B plus cos A sine B. Divide by what? Cos A cos B minus sine A sine B. So if I want to tell you now, what you just do is to divide both sides by what? Divide both sides by sine A or cos A cos B. Divide up and down by what? Divide what? Both, or that means the numerator and the what? The denominator by cos A cos B. So what do we have now? If you do that, what do we have? So I want to have it as what? That means dividing up and down. Don't forget this cos A. So what do we have now? I would have tan A plus B becomes what? Sine A cos B divided by what? Cos A cos B, then plus what? Cos A sine B divided by what? Cos A cos B, then cos A cos B divided by what? Cos A cos B minus tan sine A sine B divided by cos A cos B. So this one will cancel this one. So this one will cancel this. This will eliminate this one. So what we are left with now will now be what? Tan A plus tan B all over what? 1 minus tan A tan B is equals to what? Tan A plus B. Now that is the answer to that question. Now for that particular analysis. So now, if you want to now solve for this, go and do this one for me. If you do similar case of tan A minus B, we are going to have it as what? Tan A minus tan B. If you do it, go and try it over 1 plus tan A tan B. Try it. So that's what I want to have. So I will see you on my next class. I believe I'll be able to do all the necessary word identity. We have done sine A plus sine B. We have done sine cos A plus B. This one is called sine A plus B. We have done what? Tan A plus B. And this is what? Tan A minus B. So I believe that in our next class now, we are going to look at multiple angles of trig. That will be the last thing we are going to do. Multiple angles and half angles. And I believe you will stay tuned till that time. My name is what? Generality. Thank you for watching my video. God bless you. Ensure you subscribe and click the bell button. Thank you. Bye.